All right, so what we're doing today is very similar to the first section of 4.4 of the Pythagorean theorem. This is the converse. So we're basically doing it backwards. And I'll show you what I mean in a second. So this says, you can determine if a triangle is acute, obtuse, or right by its side lengths. So previously I said, hey, this is a right triangle. A squared plus B squared equals C squared. Now I'm saying I don't know what kind of triangle it is, and you are going to use A squared, B squared, and C squared to figure it out. Okay? So, you start with basically the Pythagorean theorem. And you decide which side's bigger or if they're equal. So if the A and the B side is the bigger one, so if C squared is less than A squared plus B squared, then we have an acute triangle. If they're equal, like they were last week when we did 4.4, we have a right triangle. If the C squared side is the bigger one, so if C squared is greater than A squared plus B squared, we have an obtuse triangle. So you're basically seeing, are the legs squared side bigger, or is the C squared side bigger? Which kind of makes sense, right? Because if this is sort of the usual one, the usual way we do it is a right. If the C is too small, that forces that angle across from C to be smaller, which would make it acute. Or here the C is too big, which would make angle C too big, which would be obtuse. So it kind of makes sense. But here it is all written out, so you don't have to reason your way through it every time. You can just check back on this chart. Any questions? So here's example 1. The side lengths are 4, 5, and square root 35. We kind of need to know what the square root of 35 is so we can decide which one is the longest side. So if you type that into your calculator, you get 4.9. So that's going to be my longest side. That's going to be my C. What did I say?
4.9.
Oh, you know what I meant.
No, we didn't.
All right. So we're going to do C squared. Which one's C?
The longest one.
The longest one, which in this case is the square root of 35. All right. So we're going to square that. We're going to use the other two sides for the A and the B. We're going to square them, add them together, see which number's bigger. Now, I'm going to go back to this guy so I get an exact answer. This just helps us see, is it bigger or smaller than these two? Okay? So I'm going to square the square root of 35. Not sure what symbol's going to go here, but I have the other two sides squared, and I'm going to add them together. So the square root of 35 squared is just 35. The square root of 4 is 16. The square root of 5 is 25. When you add those together, you get 41. So what symbol goes in between those?
Equal.
Those two are equal.
Greater or less?
That's what I'm asking you.
Greater. Less than.
The big mouth is going to eat which number?
The 41.
The 41. So that's the less than symbol. So if the AB side is the bigger one, what type of triangle do we have?
Acute.
An acute triangle is the answer. So the whole point is to decide what type of triangle these side lengths would make. Questions?
You got numbers with no triangles. Like 3, 4, 5, and 6.
I'm sorry, I'm on example 2.
Oh, my fault.
All right, so example 2, the side lengths are 8, 12, and 15. Which one has to be the C? 15. So I'm going to do 15 squared. Not sure what symbol's going to go in between them. But then I'm going to have the 8 squared and the 12 squared as my A and B. What is 15 squared? 225. What is 8 squared? 64. What is 12 squared? 144. All right, what do you get when you add those together?
225 and 208.
208. So which one's bigger? The 225. So that's the C side. If the C side is the bigger one, what type of triangle are we looking at? Obtuse. Very good. Remember, for the C side to get bigger, the C angle would have to get bigger. So if you have a big old angle, it's going to be obtuse. Questions?
No.
All right. As we just heard, the next one doesn't have a picture. It just has side lengths. We can still do the same thing. So, which side has to go first? The 7. So 7, I'm not sure. A squared plus B squared. The A and B are the 4 and the 6. All right. What do you get?
49.
49.
16.
And
36.
very good. All right, then what?
49 is less than 52.
49 less than 52. So the AB side is the bigger one, which makes the C a little bit smaller than a right angle. So this would be an acute. Very good. Number 4.
Is that a 35 or 25?
That is a 12, a 35, and a 37. Which one has to go first? 37. So 37, I'm not sure. 12, 35, all squared. What is 37 squared? 1,300. Did you say 79? 69. Okay. I was like, uh-oh. All right. And then we have 144 and 1225. Mm-hmm. Mm-mm. What happens?
1, 3, 6, 9. It's equal.
So they are equal. If they're equal, what type of triangle am I looking at? A right triangle. That's kind of, like I keep referring back to that. That's kind of our go-to with the Pythagorean theorem. Questions?
No.
Number 5. All right, which one needs to be by itself? The 36. Careful, sneak the big one in the middle. All right, so we got 36 squared, not sure. 16 squared, 30 squared.
It doesn't matter how you put the A and B. No.
The A and the B don't matter. Addition is commutative, so it'll end up being the same thing. What is 36 squared?
1,296.
1,296. 16 squared is 256. 30 squared is 900. So which side is going to be bigger?
C side.
Right. When you add those, you get 1156. So the C side is bigger, which makes the C angle bigger. So we are looking at an obtuse triangle. Good. Okay. That was our last example for the day. What are your questions? Yes, here comes the homework.